All right, everybody, so we're going to keep talking about our idea of equivalent ratios and how they have to do with mixing colors. So one of the things that we noticed is that when mixing colors, doubling, I'm going to get my pen working, doubling or tripling, the amount of each color will create the same shade. So for example, if we had 2 parts blue, 3 parts green, if we doubled that, 4 parts blue and 6 parts green, because this recipe is doubled, it still creates the same shade of the color. In fact, you can always multiply the amount of each color by the same number to create a different amount of the same mixed color. So maybe I just wanted a little bit of that amount here. Maybe I wanted more of that amount here. So my total here was 2 plus 3 is 5. My total here was 10. So I made double as much, but the color is going to be the same. So a batch of dark orange paint uses 4 milliliters of red paint and 2 milliliters of yellow paint. Draw a diagram to represent each color that would be used to create a batch. So if I need a batch, looks like I have 4 red. You can write an R in there to help you. And 2 yellow. Now just to make it so you can see my picture a little bit clearer, here's red, 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 yellow, yellow. There's my diagram. So this is just for one batch. So I have 4 red over 2 yellow. I'm just writing a little fraction in there to help me remember. To make 2 batches of this dark orange paint, we're going to need 8 milliliters of red with blank milliliters of yellow. So I started with 4 red, 2 yellow. These are equal, but now I want to get to 8 red. Well, when I do this, I am doubling. I'm timesing by 2. So it looks like I'm going to need 4 yellow. All right, next one. Draw a diagram to represent creating those 2 batches of dark orange. So I could see up here I had 8 red, so 1, 2, 3, 4, 5, 6, 7, 8, and 4 yellow. 1, 2, 3, 4. So I'm going to color code these. Again, you can just write R and Y for red and yellow in your boxes. I have some nifty highlighter colors right here, so I just got to highlight. So we can say the ratio of red to yellow. Oh, I'm sorry. It is red to yellow, but we can make different amounts. So we can have, originally it was 4 to 2. We could say 4 to 2. We could say 8 to 4. You know, we could have taken that original amount and we could have multiplied it by 3 even. So we could keep going with this list. We do 4 to 2, 8 to 4. If I wanted to go again, I could do 12 over 6. As long as I'm multiplying by the same number, multiplying my original by the same number, it creates things that have the same color mixture. So we can say these are equivalent ratios because they describe the same mixture in different numbers of batches, but they're going to make the same shade of orange. So although my amount of how much I have in total keeps getting bigger, since the ratio stays the same, the color stays the same. All right, so to make the perfect green tea, you're going to need 6 parts water to 6 parts tea packets. Explain how you can make 3 batches of that iced tea. All right, so if I have a 9 parts water. And I have 6 parts tea. I'm going to use what I know about equivalent ratios. Now, I want 3 batches. So I'm going to multiply this by 3. So 9 times 3 gives me 27 water then. 6 times 3 gives me 18 tea. So I need 27 parts water and 18 parts tea packets. So that's what you describe as your perfect amount of tea for 3 batches. Now, if you look down here, your neighbor comes over and tries your tea and thinks it tastes a little bit strong. So it has a really, really intense tea flavor. And maybe that's not their favorite. So could you make a new batch that was not as strong? What would you do? Well, you can do the same thing. So if you use 27 parts water again, you need to use less than 18 parts tea. Or truthfully, anything that is equivalent to 9/6, but that 6 is going to be smaller in this case. All right, that's all we have for today.